Hello, today we'll be talking about dynamic memory allocation. So basically in C, we can allocate memory in two different ways. One is static memory allocation and dynamic memory allocation. Here is an example for static memory allocation where we are initializing A of 8. That means we are allocating 8 blocks of memory. But the thing is we are just using 4. The other 4 is getting wasted. So to overcome this issue, we can use dynamic memory allocation which allocates memory at runtime. So static memory allocation allocates memory at compile time, whereas dynamic allocates memory at run. So dynamic memory allocation is a inbuilt function which is available in stdlib.h header file. So coming to why dynamic allocation. So it reduces memory waste and it is also useful for data structures like linked list, trees, etc. So dynamic memory allocation in C have three functions for allocating memory and one function for deallocating the memory. Malloc, calloc, and reloc are the functions for allocating a memory and free is the function for deallocating the memory. Coming to the first one that is malloc. So malloc, the full form of malloc is nothing but memory allocation. So this allocates a block of memory for specified size. So coming here we can see the syntax malloc of size. That is nothing but so whatever size we give here, that that number of bytes is gonna allocate. That number of bytes of memory is allocated. So basically malloc returns a void pointer. Returns a void pointer. So void pointer is nothing but base address, the base address of memory or the address of first byte in the memory. That is void pointer. So in generic, we can use void pointer. Uh, when we don't know what value we're gonna enter, we can use void pointer. But when we know it, like here, we know it that we are giving integer value. So we can use int pointer. So malloc 20. So 20 bytes is allocated and the first byte address is written. So again, using 20 is not a very good practice. We have to use n into size of int. So imagine n is 3 and size of int is 4. So size of int can be 4 or 2. It basically depends on your machine. So size of int, here let us assume it is 4. So size of int is 4 into 3, that is 12. So this malloc function allocates 12 bytes of memory and the base address of first byte is written. Here we are using int pointer because we are entering integer value and that address is stored in B. We will see a code simple program. Here is a simple program. So hash include stdlib as I said, malloc functions is basically present in this header file. So we are declaring nin pointer. So enter the number of elements n that is stored in n. So coming to the function declaration, int asterisk malloc n into size of it. Now let us imagine that the number of element is 3. That means we're going to enter 3. 3 values. So that 3 into size of it. Size of int is 4. Let us assume it as 4. So that size of int into 3 that is 12. So this malloc function allocates 12 bytes and then returns a first byte address to the pointer and then that is assigned to pointer. So okay. Now it is the user time to enter the value. So for that we're going to use for loop here. And here we are using pointer. So, and we are not, if you can see, we are not using the and symbol here because pointer itself is a address and we can enter values using address also. So that is an example here. And that values can also be printed by using the same for loop that is I is equal to 0, I less than n, I plus plus. Here we're using asterisk symbol because asterisk is an indirection operator which gives the value. So we'll see the output. So here see, enter number of elements is 4. So 4 into 4, it is 16. So that means it allocates 16. So imagine the first base address is 2000. So that 2000 is stored in PTR. Okay. So now when I is equal to 0, 2000 plus 0, it is 2000. So now this pointer points to 2000 address. So that 2000, in 2000 address, the user has to enter some value. So imagine I have entered 12. Again, I is incremented now. I goes to 1. So when it is 1, 2000 plus 1, 2001. 2001, enter the value 25. Again, 2. 2 is less than 4. Yes. So then again, the loop goes on like. So when it is 4, 4 is less than 4. No, it exits from the loop. Then it prints the value. And here we're using free PTR because to reduce the memory leaks, we are freeing the memory that is allocated here. So here, as we have allocated 16 bytes here, at last we have to free the memory. That is best. And also imagine you have commented this 4 line, that is a prompt for user. Imagine you have commented this code. At that time, malloc returns some garbage value. Returns some garbage value. If you don't, if user does not give any value, then it returns the garbage value. If it cannot allocate the memory, so this is another case. If it cannot allocate the memory from the heap, just imagine the memory is n and you're asking for n plus 1 memory block. Then, because it cannot allocate, that time it returns a null point. In case of failure, it returns null point. That is about malloc. And malloc is basically, in general, it is used for structures. For structures, that is again another point. Um, So coming to calloc, calloc is a contiguous allocation. So basically in calloc, the basic difference between calloc and malloc is malloc allocates block of memory, just allocates a block of memory. Whereas in calloc, it allocates a multiple block of memory. It dynamically allocates multiple block of memory and each block is of same size. That is the difference between malloc and calloc. And here it is in general used for arrays. That when I say it is in general used for arrays, that doesn't mean it cannot be used for structures. But basically, it is in general we'll use it for arrays. So syntax is same, but the only thing is here we use two arguments. One is n, that is the number of values that you're gonna give, and size is again size of data type. And one more thing is initially, when malloc creates a block of memory, it stores a garbage value. But when it comes to calloc, it initializes 0 as its initial value. It initializes 0. That is the another difference between malloc and calloc. In coming to example, 10. Just imagine here it is 10. That means you are entering 10 values, then size of int. So size of int is 4. So 4 into 10, it is 40. So 40 bytes is getting allocated by calloc of each of same size. That means 10 block. 10 block is allocated each of size 4. So that is how calloc works. So again, here we're going to use n for best practice. Um, a simple program. It is almost same to the malloc. The only difference is this declaration. Here we are using calloc. Just imagine again. We'll see output and then we can compare it. So 3 is n, and then size of integer is 4. So it is like 3 blocks, size of 4. Size of 4 is being created, and initially it is all same, and then we're gonna print it. But here again, as I said, if we comment it here, like if we comment this particular 4 lines of code, 4 or 5 lines of code, that is entering the values, then if the user doesn't enter any value, then the calloc returns Here the value will be 000. In case of malloc, it was garbage value. When the user was not entering the values, it was garbage value. But here it is 0 because initially calloc allocates 0 as its initial value. Again, at last, we have to free the memory. That is it. And yeah, that is it. So coming to conclusion part, it is all the same thing. See, don't forget to use free to release allocated memory and avoid memory leaks. This is something best practice that one can have. And thank you. That's all.